All right, today we're going to delve a little bit into ionic bonding. Ionic bonding is a way for atoms to satisfy the octet rule by transferring electrons to each other. Ionic bonds usually happen between a metal and a non-metal. And if remember that metals are on this side of the periodic table and non-metals are on this side of the periodic table. And once they've transferred the electrons, you're going to have a cation and an anion, or a positively charged ion and a negatively charged ion. And you'll remember that we said that opposite charges attract. So once you have these opposite charges, they are attracted to one another, and that's how they're held together. So I'm going to start with sodium chloride, which we talked a little bit about at the end of the last video when we were talking about properties. So if I look at the dot structure for sodium, you recall that sodium, being over here on the left-hand side, has one valence electron. And so I'm going to draw its dot structure like this. Chlorine has how many valence electrons? Hopefully you said 7. And so when I draw the dot structure for sodium, 1, 2, 3, 4, 5, 6, 7. Now let's review what we said sodium wants to do. What does sodium want to do? It wants to look like a noble gas, so it wants to get rid of this electron. What does chlorine want to do? Well, chlorine also wants to look like a noble gas, so it wants to gain one electron. And I mentioned in the last video, those electrons can't just come from outer space. They can't just come from no place. They have to come from someplace. So since sodium wants to give up its electron and chlorine wants to gain its electron, sodium says, hey, that's cool, I'll just give you my electron. And so it goes over here like that, and then once that happens, sodium no longer has its electron and it has a positive charge. Chlorine now has another electron that it just gained from the sodium, and it has a negative charge, and so now the positive and the negative charges attract each other, and I have a compound made up of one atom of sodium and one atom of chlorine. Okay, see how that works? All right, what happens though if I have, in place of sodium, what happens if I have an atom of oxygen? So my sodium has one valence electron here. Oxygen is in group 16. It has 6 valence electrons. So I'm going to go 1, 2, 3, 4, 5, 6. Oxygen wants to do what? Well, if you remember, oxygen wants to gain 2 electrons. Sodium wants to give it up. So sodium gives one of its electrons over here. So this sodium is quite happy. Is the oxygen happy? No, he's still an electron short. He has 7, but he doesn't look like a noble gas yet. He needs 8. So how am I going to fix that problem? Well, what I'm going to do is I'm actually going to bring in another sodium atom, and it's going to take its electron and it's going to give it to the oxygen as well. So once that happens, what do I end up with? Well, then I have this sodium has a +1 charge, and I have this sodium that has a +1 charge. And now my oxygen has 2 extra electrons, and it has a -2 charge. And you'll see that that's where these charges came from. We said that everything in this column has a +1, everything in this column has a -2, right? Okay, so what that means is that in order for all of this to work out right, I have to end up having 2 sodium atoms and 1 oxygen atom. So when I write the formula, I write an Na, capital N, little a, with a 2 because I had to use 2 of them. And then for the oxygen, I needed to use just 1 of them in order for that to work. Okay, sometimes it works out a little bit nicer. So if, let's say that I started with calcium. Calcium normally has how many electrons? Well, calcium is right here, and so being in that second column, it has 2 valence electrons. It wants to give up its 2 electrons. Oxygen wants to gain 2, so one of them is going to go here, One of them's going to go down here. Is calcium happy? Yeah, because it got rid of both of them. Is oxygen happy? Yes, it gained 2, and it now has a full outer shell. So now, if I draw the final structure here, calcium has a positive 2 charge, oxygen has a negative 2 charge, and so to write the formula for this compound, I have 1 calcium and 1 oxygen. Okay, C, capital C, little a, capital O, right? What happens if I have this? I have a calcium that has 2, and then I have a fluorine, and fluorine has, since it's here, it has 7 valence electrons. What does calcium want to do? It wants to give up 2. What does fluorine need? It needs 1 more. So calcium can give 1 of its electrons over here. What's it going to do with this one? Well, hopefully we've got another fluorine atom hanging around. And if we do, then this electron can go down here to this fluorine. So final structure here then means that I've got this electron is now down here, which gives this a -1 charge. This electron is now over here, which gives this fluorine a -1 charge. The calcium's gotten rid of 2 of them, so it has a +2 charge. So if calcium and fluorine are going to get together to make a compound, it's going to take 1 calcium atom and 2 fluorine atoms. Okay, CaF2, capital C, little a, capital F, but this is called a subscript with a subscript of 2. You ready for a complicated one? Let's try one that's a little bit more complicated. Let's say that I have magnesium and a nitrogen. What do I have there? Well, magnesium has how many valence electrons? Can you figure it out? It's over here on the periodic table. It has 2 valence electrons. What about nitrogen? How many does it have? Well, if you said 5, you're right. So 1, 2, 3, 4, 5. What does magnesium want to do? It wants to lose both of those. What does nitrogen want to do? It wants to gain 3. So how am I going to make this work? Well, I could take 1 electron and I could put it up here. I could take 1 electron and I could put it here. Is my magnesium happy? Yeah, sure is. Is my nitrogen happy? No, he's still 1 electron short. What am I going to do about that? Well, if I bring in another magnesium, he has 2 electrons. And so 1 of the electrons can go here, so that nitrogen's happy now. But is my magnesium happy? No, he's like, I got 1 more electron to get rid of here. I'm not happy yet. So let's bring in another nitrogen with its 5 electrons. So this electron can go here. Magnesium's happy. The nitrogen still has a problem. He's now 2 electrons short. So let's bring in 1 more magnesium. So this magnesium is going to go, this electron's going to go here. This electron will go down here. Is this magnesium happy? Yes, he got rid of both of them. Is this nitrogen happy? Yes, he gained 3 electrons. And so what's happened now is that my magnesiums have all gotten rid of their electrons. I'll get rid of these arrows here. So all of the magnesiums have a +2 charge because they all had 2 to get rid of. The nitrogens all gained 3, so they have a -3 charge on them. Get those drawn back in since they got erased. And so when I draw the formula for this one, how many magnesiums did I use? 1, 2, 3. I used 3 of them. How many nitrogens did I use? 1, 2. I used 2 of them. So the formula for a compound that magnesium and nitrogen make together is Mg3N2 because I used 3 magnesiums and I used 2 nitrogens until I got the electrons moved around and I got it right. Now, just because I'm showing you here how to transfer these electrons does not mean that you have to do that every single time that you're trying to figure out what the formula for a compound is when I give you two elements. So, I mean, you can do it that way, but it takes a lot of paper and a lot of time, and I bet there's an easier way. But hopefully you have this picture in your head of how it works. So let's say that I wanted to do, let's say that I wanted to put together potassium and sulfur. Let's say that I wanted to do those two. What charge does potassium usually have when it wants to make an ion? Well, if you look over here, it's in this first column. And we said everything in this first column wants to lose an electron, so it'll have a positive 1 charge. So this will be a positive 1. Sulfur is right here. It has 6 valence electrons. It wants to gain 2 to look like a noble gas, so it will have a negative 2 charge. Well, if you just think about your positive and your negative numbers, if this is a positive 1 and this is a negative 2, and they have to add up together to be neutral and make 0 so everybody's happy, what that means is that if he wants to gain 2, there have to be 2 potassiums there. So a formula between these two guys is going to be K2S. Another way to think about this is if you write these two elements to make the charge, then you can take this number and you can bring it down here, and this is actually a 1, we don't normally write the 1. I can take this 1 and I can bring it down here. So the 2 becomes here, and the 1 goes down here, so it's K2S. Okay? That's a trick that you can use. I'm hoping that you understand the concept behind it so that you can understand the trick as well. Let's try one more. Let's say that I have an atom of aluminum, and let's say that I want to combine that with bromine. What's the charge on aluminum? Well, if you remember, it's a metal and it's right here, and it wants to have a positive 3 charge. Bromine wants to gain 1 more electron, so it's going to have a negative 1 charge. Well, in order to make this balance, a positive 3, I'm going to have a negative 3 to make it balance. So that means I'm going to have 3 of these bromines. So the formula is going to be an AlBr3. Again, I can take that 3 and put it down here. I can take the 1 and I can put it down there. AlBr3. So I have 1 that has a positive 3 charge, and I have 3 that have a negative 1 charge, and so that's going to make a positive 3 and a negative 3, then we'll add up to 0. So AlBr3. Okay? So you guys now are going to get some practice writing the formulas for some different ionic compounds.